Tyre selection. When we look at tractor tyre selection, there's a number of criteria we have to take into consideration. Firstly, the vertical load on the tyre and the tangential pull, which we'll discuss later on, whether we're going to use duals or singles, whether we're going to use radials or bias ply tyres, or the size of the tyre, the diameter of the tyre. So if we get back to the first point, the most important consideration is the vertical load on the tyre. Now that's the load bearing vertically down on the tyre, which we've calculated by weighing the tractor and setting our tyre pressure accordingly. The second is the tangential pull on the tyre, or the torque loading on the tyre, where the rim is trying to turn its way out of the tyre. This is an important factor as far as the integrity of the sidewall goes, and we can see that if we're overstressing the tyre, we start to see a crease at 45 degrees down the side of the tyre. These can ultimately lead to total tyre failure. Now, tangential pull is normally in the region of 85 to 90% of the vertical load on the tyre, and in most situations we're pulling 35 to 45% of this load in the field, so tangential pull should not be a problem. If we go above those levels, we're certainly going to get high degrees of wheel slip, and in the end, or the end, we're going to see tyre failure due to the sidewall breaking down. The second factor, do we use duals or do we use singles? If we can do the job on a single tyre operating at a pressure acceptable to the load, then we must use single tyres. We see a tendency in a lot of cases to over-tyre a tractor in the belief that a greater amount of tractive efficiency is going to be gained. This in a lot of cases does not happen when we put a dual on when we don't necessarily need it, and all we do is carry around an extra tyre, and in a lot of cases we reduce our tractive efficiency because we're increasing our rolling resistance of the total package. So if we can get a single to operate, and we normally look at setting our tyre pressures of 85 kilopascals or 12 psi as the minimum, if we can get tyres to operate to that level or in that region, then we're going to get a tyre which is going to operate efficiently. We only go to duals when we have a load factor on the tyres which a single tyre cannot tolerate. Radials or bias ply tyres. There's always a lot of controversy whether we should use radials or bias ply tyres. We're seeing a lot of radials introduced into the industry. Radials certainly have their benefits, and probably the main benefit is in tyre life. Because of the belt construction in the tyre, there is less tendency or less movement of the lugs in the contact patch, so overall tyre life is improved. Tyre sizing, tyre dimension. Once again, we've seen a tendency to move to higher and higher diameter tyres, and the higher the diameter tyre, the greater traction is gained out of this tyre. The reason being is the footprint is long and narrow and generates a high amount of traction. Other benefits of tall tyres is the lower rolling resistance, and if we have a look at the diagram, we can see why. The angle that the tyre comes out of the ground at is less than a small diameter tyre, hence the reduction in rolling resistance. This also gives us a lower level of soil compaction. Tall tyres are certainly better self-cleaning. As they roll through the contact patch and come out of it, they shed mud very, very easily. Tyre life is much improved because of the longer footprint. Finally, tyre life. When we look at tyre life, farmers are often concerned when they put new tyres on their tractors, and within the first 50 hours it appears that the tyre is worn very, very quickly. This in a lot of cases is quite true, because when one considers a new tyre, the lug is very high, and when the tyre rolls through the ground, generating traction, the lug tends to move. And that's what causes tyre wear. As the lug moves backwards and forwards, the tyre wears. Well, then we get down to a situation where the tyre appears to settle down. And this is normally in the region of about 25 millimetres of rubber remaining, and we find we generate the best levels of traction at that height because there's less movement of the lug in the soil, and the tyre wear seems to settle down, or appears to settle down, and the tyre runs out its life. Of course, this is not the only contributing factor to tyre life. Soil conditions, we find in the Darling Downs area, in the heavy clay soils, we can get hours as low as 1,500, and then if we go across to sandy soils of, say, Western Australia, we find that we can get up to 6,000 to 7,000 hours out of a set of tyres.